Hey, fabulous students. It's time for us to take a look at assignment 57. And here we're just going to be reviewing graphing rationals. I got tired of saying you need more practice with this, and instead have decided to let's just do some more practice with this. All right, so all of these are going to be problems that I suggest strongly you go and try them on your own before you watch the part of the video where I go over them. We'll start with the basic ones. With only one vertical asymptote, we'll move on to two vertical asymptotes. We'll remind ourselves about what to do with no vertical asymptotes, and we'll take a look at situations with slant asymptotes and with holes, and of course, with both. All right, here we go. Number one, y equals 3x plus 1 over 2x minus 5. Okay, now I am going to say this is assignment 57 and it's review. So I'm going to go through these at a pretty quick pace. If you want the slower pace, you should probably go back to assignment 55 video where I spend a lot of time talking about the basics. Okay, pause that video, graph this one up. Hey, welcome back. I know I set the top equal to 0 to find an x-intercept. I set x equal to 0 to find a y-intercept. I set the bottom equal to 0 to find a vertical asymptote. And my horizontal asymptote, since these degrees are the same, I look at the ratio of leading coefficients. HA is y equals 3/2. So we plot what we know. I know a vertical asymptote at 2.5 and a horizontal asymptote at no room over there. How about that? Y equals 3/2. We have a y-intercept of negative 1/5 and an x-intercept of negative 1/3. So I need to connect those dots and keep going and bend to that asymptote and keep going and bend to that asymptote. Now, I don't know if I'm up here or down here. Actually, I do know. It's up here. If it were down here, I'd need another x-intercept. I don't have any more. But I'm going to plot a test point of 3 just to confirm that the y value in this function is above the horizontal asymptote y equals 3/2. So if I plug a 3 in there, I get 9 plus 1 is 10 on top. And 3 times 2 is 6. 6 minus 5 is 1. So my y value at 3 with this function is 10. The horizontal asymptote is 3. 10 is much higher than 3. 3, 10. And I bend to the asymptotes. There's our first one. All right, let's keep going. Y equals, change my mind. Y, this is number 2. Y equals 3 minus 2x, 4x plus 1. All right, pause the video. Come back in a few minutes when you're done. I'm kind of interested to know what you said about the horizontal asymptote. Did you say 3/4? I hope not, because y equals negative 2 over 4, or negative 1/2 is our horizontal asymptote. Sometimes people take the first numbers. We need the numbers in front of the x's. That's what my coefficient is, and that's what my coefficient is in the denominator. We want the ratios of the coefficients on these variables, not these numbers here. These numbers, the ones attached to x's. Okay, vertical asymptote, x equals negative 1/4. X-intercept, we have to set this equal to 0, which means we're going to get x equals 3/2. And the y-intercept, when we set these x's equal to 0, is going to be positive 3. All right, let's give a graph. We have a vertical asymptote at negative 1/4. We have a horizontal asymptote at negative 1/2. We know the x-intercept is over here at 3. We know the y-intercept is up here at 3. We're going to bend to that asymptote. We're going to bend to that asymptote. What about on this side, to the left of this vertical asymptote? Well, I'm going to try in a value over here like -1. -1 times -2 is 2, plus 3 is 5 on top. -1 times 4 is -4, plus 1 is -3. That's -5/3. Is that below the horizontal asymptote or above? Well, the horizontal asymptote's at -1/2. Less than 1. This is more than 1. So we're down here. We're down here. In fact, I'm going to let it breathe a little more. And so I'm going to have -1, -5/3. There's my point. Okie doke. Feel free to send me a message on GroupMe. Ask in our next synchronous Zoom what any questions you have about these. Okay, number 3. How is this one different? X plus 5 over x squared minus 1. That's right, 2 vertical asymptotes. We've got vertical asymptotes at x equals plus and minus 1. My x-intercept comes from setting the top equal to 0. My y-intercept comes from putting in 0 for x's, so I have 5 over -1, or also -5. And horizontal asymptote, since the degree here is 1 and the degree here is 2, we know the degree on top is smaller than the degree on the bottom, and so we say y equals 0. All right, so what's our graph look like? Well, we got a vertical asymptote and a vertical asymptote at -1 and 1. We have an x-intercept at -5. Well, if this is -1, -5's got to be to the left. Yes, I know it's not in scale, but that can't be 1 if that's 4 more. But shh, don't tell. Okay, and a y-intercept of -5. Horizontal asymptote at 0. All right, so what do I do? Well, my recommendation is, of course, that you take a look at what your choices are in between 2 vertical asymptotes. Remember, we might have this shape, we might have this shape, we might have this shape, and we might have this shape. Which one can we have here? Can I have that one? No, because that's an x-intercept, and my only x-intercept lives way over here. So I can't have that one. How about this one? Yeah, I agree. I can't have that because that's another x-intercept. Can't have that one. How about this one? That doesn't have any x-intercepts. That's cool. Except this is a positive y-intercept, and our y-intercept is -5 down here. So that's not going to work. Well, I hear you. What if we take that parabola and drag it down so that it does pass through there? Well, that's fabulous, except I need 2 more x-intercepts, and I've only got the 1 still over here. So that's not going to work. Okay, so what's my only choice? Doink, doink. Great, so we got the middle of the graph done. Now, what about here? Am I up here or am I down here? This is x equals 1, so let's test something to the right of x equals 1. I don't know, how about x equals 2? 2 plus 5 is 7. 2 squared is 4. 4 minus 1 is 3. Is that above the horizontal asymptote or below the horizontal asymptote? It's positive, so my graph goes up here, and I'm bending to the asymptotes. I don't recommend starting so close to the edge of the page, but I will label this point as 2 7/3. Please make sure you label the point on the graph. Okay, last part. This part over here, to the left of x equals -1. Remember, I've got 2 choices here, just like I did over here, but one of them passes through the horizontal asymptote and comes up. The other passes up through the horizontal asymptote and comes back down. and we need to figure out which of these we have. Well, this is -1, this is -5. I could choose a value in here and see whether I get this or this. Or I could come out over here and choose a value over here to see if I get this or this. It doesn't matter at all, but I think you should be thinking about what you're doing and not just trying to do what you're doing. That thinking process is kind of important with this stuff. So I'm going to check -2. -2 plus 5 is 3. -2 times -2 is 4. 4 minus 1 is 3. 3 over 3 is 1. So at -2, I got a 1. Which means this blue one is not my graph. Okay, I've got that x-intercept, I have a test point to confirm. Yeah, I don't know how low that goes, and I'm not going to bother because if I'm really desperate, I'll try and graph it on my calculator, though really, oh my goodness. Trying to see these things on a graphing calculator, very, very challenging unless you already have a good idea what viewing window to use, i.e. hand graph it first. When we're in calculus, we'll have a way of conveniently finding this. So really, I'm not going to stress about it now. Okay, next. How about this one? Y equals x minus 1 over x squared minus 4. Will you do that one, please? All right. So, did you say that x equals 1 is the x-intercept because you set the top equal to 0? Good job. Did you say that the y-intercept was 1 over 4 because you set all the x's equal to 0 and a negative divided by a negative is a positive? Did you say when you set the denominator equal to 0 that you had vertical asymptotes not at plus and minus 4 but at plus and minus 2? I hope you did. And then finally, we look at the degree on top and at the degree on the bottom. We see the degree of the top is smaller than the degree on the bottom, and so we know I have a horizontal asymptote at y equals 0. So we draw. We go y equals 0. Please make sure we label that horizontal asymptote y equals 0. We have vertical asymptotes at x equals 2 and x equals -2. I have a y-intercept of positive 1/4, and I have an x-intercept of 1. Is 1 over here or over here? Well, if this is 2 and this is 0, I got a 1 here. All right, so what did you think about? Did you think about this one? And why is that not a good choice? Why doesn't that work? That's right. This requires a second x-intercept, and I've only got this one here. So the only shape I'm going to have here is that shape. Okay, what next? Well, we've got to figure out up here or down here. We've got to figure out up here or down here. So let's use some test points. If I test -3, -3 minus 1 is -4. -3 times -3 is 9. 9 minus 4 is 5. So I get -4/5. The ordered pair, -3, -4/5. That's this point. So my graph is going to be down here and not up here. Don't forget to bend to the asymptotes. And finally, what about over here? What if I plug in a positive 3? 3 minus 1 is 2. 3 squared is 9. 9 minus 4 is 5. I get positive 2/5. Well, that's going to be up here. So my graph is going to go like this through 3, 2/5. Okay, any questions? Well, I hope if you do have them, that you keep asking about them. All right, how about this one? Y equals x minus 3 over x squared minus 4. Pause the video, give that one a try, please. Okay, we know the x-intercept is equal to 3 from setting the top equal to 0. We know the y-intercept is 3/4 because we plug zeros in for x's. We know the vertical asymptotes. Don't forget plus and minus 2. You can't forget the plus and minus. You can't take the square root of the. You can't forget to take the square root of the 4. Some people find that setting this equal to 0 and adding 4 and then taking the square root um, is much more problematic for them than seeing this as a difference of squares and saying, oh, well, that's x minus 2, x plus 2. I will say that these factoring seeing people, they don't get these vertical asymptotes wrong very often. But often with the people who solve by taking the square root of both sides, yeah, for some reason here, they either forget the negative one or they put a 4 here. So watch out for those things. All right, so we've got our vertical asymptotes. What about a horizontal asymptote? The degree here is 1, the degree here is 2, so we know y equals 0 is the horizontal asymptote because the degree of the numerator is less than the degree of the denominator. So let's graph what we know. We know we have vertical asymptotes, -2 and at +2. We've got an x-intercept of 3, that's over here, and a y-intercept of 3/4. 3/4. Okay, and don't forget the horizontal asymptote at y equals 0. Okay, so what can I have in between? Can it be this one? No, because that needs an x-intercept. Can it be this one? No, because that needs an x-intercept. Can it be this one? No, because that would need two x-intercepts. Can it be this one? Well, it doesn't have any x-intercepts, but it misses that y-intercept. So our only choice here that actually goes through that y-intercept is this point. Okay. Now, what about over here? This is x equals -2. So I want something to the left of -2, -3. I'm going to have -3 -3 or -6 on top. -3 times -3 is 9. 9 minus 4 is 5. So I get -6 fifths. -3, -6 fifths is that. Okay. And what about over here? Is it going to be this part that comes down and goes back up? Or are we going to have this part where we go up and come back down? I won't know unless I test a point. I generally like plugging in whole numbers into stuff like this, and since this is 2 and that's 3, yeah, I'm not going to go with something in between them. I'd rather go with 4. So if I go with 4 and get a positive output, it's the blue part of the graph. If I go with 4 and get a negative output, then I'm going to have the green part of the graph. So let's see what happens when we plug in a 4. 4 minus 3 is 1. 4 squared is 16, minus 4 is 12. Positive 112 and 4. So 4, 1, 12. And I have to cross the x-axis. Sorry, this is 4. I have to cross the x-axis of 3. So I'm going to go up and come back down. And really, we should come back down. Yeah, I'd be very uncomfortable scoring that for full credit, so give yourself some space, unlike me. I needed workspace. Yeah. Okay. We could do one more. I don't want to, though, but I kind of like this one. How about this? X squared minus 1 over x squared minus 4. Let's see how fast we can do this one correctly. Hey, welcome back. I set the top equal to 0. I get x equals plus n minus 1. That means I have two x-intercepts. My y-intercept is 1/4. My vertical asymptotes, because I can factor this difference of squares, or I can add 4 and take the square root, I get plus and minus 2. And my horizontal asymptote, well, look, the degrees are the same this time. So I'm looking for the ratio of leading coefficients. So y equals 1. Well, let's graph what we know. We know we've got these two vertical asymptotes at 2 and negative 2. We have x-intercepts at negative 1 and 1. We've got a y-intercept of 1/4. We have a horizontal asymptote at y equals 1. Okay, so what shape are you going with between the vertical asymptotes? I'm not going with that. No, I'm going to go with down-pointing parabola. Okay? Now, what about over here at 3? What about here at negative 3? Well, look, we know already we had two x-intercepts, and we've used them. So we're not going to be having any x-intercepts over here because we used all the ones we had already. I know that I'm going to have up here and that I'm going to have down here. But I still need you to label a point on each of these pieces. So if I plug a 3 in there, 3 squared is 9, 9 minus 1 is 8. So I get 3, 8 over 9 minus 4 is 5. Well, 8/5 is definitely bigger than 5/5, or 1. How about if I plug in a negative 3? Well, look, negative 3 times negative 3 is still 9. Minus 1 is 8. And negative 3 squared is still 9. Minus 4 is 5. And so I get the same y value over here. At negative 3, I get a y value of 8/5. And there's my graph. All right. So, two vertical asymptotes, no problem. How about this one? Y equals x squared plus 1. So this is no vertical asymptotes. When I think about the graph of x squared plus 1, how many x-intercepts does this graph have? None. This graph is never equal to 0. So this denominator is never going to be equal to 0. Not with real numbers. It can be with imaginaries, but we're not graphing imaginaries. So, no vertical asymptotes. I set the top equal to 0. I get x equals 0 for my x-intercept. If I put zeros in here, I've got 0 over 1, which is 0 for the y-intercept. So we're passing through the origin. And since the degree of the top is smaller than the degree of the bottom, we know y equals 0 is the horizontal asymptote. Now, many students find this terribly uncomfortable because, what do we know? Not much. We know that we're passing through the origin. We also know that there's a horizontal asymptote at 0. And I think the phrase, Kukla, you're killing me, is not ill-advised at this moment. But this is all we've got. As my grandfather used to say, we work with what we got. So let's plug in a test point like 1 or negative 1. 1 squared is 1 plus 1 is 2. I got 1 over 2. Positive 1/2 at x equals 1. So 1, 1/2. Nice. What happens when I plug in a negative 1? Well, negative 1 times negative 1 is still 1. 1 plus 1 is still 2. But on top now, instead of having positive 1/2, I got negative 1/2. Negative 1, negative 1/2. Now, it would be easy to draw a line through those. And it would also be wrong. Because remember, in this problem, we've got a horizontal asymptote that we have to approach. So even though I'm going through the points, I have to come back down. Even though I'm going through the points, I have to come back down. In calculus, I'll show you a nifty, easy way to find where these maxes and mins are. But in our class, look, I don't know if the graph does this or if the graph does this. I just don't know. And I really don't care. These are supposed to be fast graphs. All of these things tell me first increasing, then decreasing. All positive. I don't need anything more than that here. So, don't stress about that. But do have something that crosses through the origin and comes back down to the asymptote, crosses through the origin and comes back down through the asymptote. Okay? I will say that usually these y values are opposites, but not always. So I'm not going there at all. All right, so I think it's time for you to do one. How about this one? Y equals 3x minus 1 over x squared plus 3. Please graph that rational function. Come back when you're done. All right. So we've got an x-intercept at 1/3. We have a y-intercept at negative 1/3. We've got no vertical asymptotes. What do you mean, no, we don't? We have some vertical asymptotes. Are you sure? Here. X squared plus 3 equals 0. X squared equals negative 3. And now I'm taking a square root. And I can't take the square root of a negative number without using imaginaries. So, no, sorry, my graph has no vertical asymptotes. But my graph does have a degree here that's smaller than the degree here, and so y equals 0 is the horizontal asymptote. All right, so what do we have? We have horizontal asymptote at 0. Please make sure you label it in case I don't see your dots. And we know we have an x-intercept at 1/3 and a y-intercept at negative 1/3. I need to connect these dots, cross, and come back down. I need to connect these dots and come back down. There's my graph. Okay. How about this one? How is this one different? Okay. Y equals 6x squared minus x minus 2 over 3x squared minus 11x plus 6. I know, kind of exciting. I mean, no problem to do the y-intercept at negative 1/3. And the horizontal asymptote, since the degrees are the same, I'm just looking at the ratio of leading coefficients, 6/3, or y equals 2. So I know horizontal asymptote, y equals 2. I know y-intercept of negative 2/6, or negative 1/3. But I still need to deal with vertical asymptotes and x-intercepts, and that's going to require me to factor. This is, in fact, one of the reasons why we did algebra basics before we did this graphing, right? I need to be comfortable factoring these quadratics in order to graph some rational functions, which is why we didn't put rational graphing in the graphing basics section that we did first. So how does this factor? Well, I'm going to have a 2x and an x, a 3x, and a 2 and a 1. This should be a minus, and this should be a plus. On the bottom, I'm going to have 3x and x, 3 and 2, and both of these are negative. Okay, what do you see? I agree, there's an x-intercept at negative 1/2, and it looks like there's an x-intercept at positive 2/3. But vertical asymptotes, it looks like there's a vertical asymptote at 3 and a vertical asymptote at positive 2/3. So what's the issue here? Well, these are the same. So what we really know is there's a hole at x equals 2/3. There's a vertical asymptote only here at 3. There's only an x-intercept here at -1/2. So let's graph. Remember, when we're graphing this, I don't want to try and graph this because I'm going to get some sad places. I want to factor. I want to cancel the factors. Remember that they're wholes or a whole. And this is what I'm graphing, really. This over this. It's the same as this graph, except here it's easier for me to see that there should be a whole at 2/3. Okay. So graph x equals 3. Nice. The degree here is 2. The degree here is 1. 2 over 1. I'm sorry. The degree here is 1. The degree here is 1. So I'm looking at the ratio of the coefficients to get the horizontal asymptote of 2. And I can get that either here or here. Okay, what's next? We know a y-intercept of -1/3, an x-intercept of -1/2. We've got a whole at 2/3 and a vertical asymptote here. So 2/3 is going to be somewhere in here. So a whole at 2/3. And if I plug in a test value like 4, I know it's not going to be this piece because that piece requires an x-intercept. I don't have an x-intercept over here. So when I plug in that 4, and you can plug the 4 into all these x's, I'd rather plug the 4 into this simplified thing. So I'm going to have 9 on top, and 4 minus 3 is 1 on the bottom. So I get 9 for the y value at 4. Is that above the horizontal asymptote y equals 2, or below the horizontal asymptote? Well, this is 9. When I plug in a 4, I get a 9. 9 is bigger than 2. So my graph is going to do this. Don't forget to label that test point. All right, don't forget the whole. It's kind of sad when we forget the thing that makes this problem different from all the others. Okay, so why don't you do this one? Y equals x plus 2 over x squared minus 2x minus 8. Give this one a try. All right, so here we go. We've got x-intercept -2 because we set the top equal to 0. You know, this does factor. X minus 4, x plus 2. Uh-oh. There isn't an x-intercept at -2. There's a whole. All right, I see one vertical asymptote. And really what I see is this is the thing that I'm left with. This is the thing that I'm graphing. If I set the top equal to 0, 1 doesn't equal 0. There are no x-intercepts. If I set x equal to 0, I see 1 over -4, or the y-intercept is -1/4. And since the degree here is x to the 0, and here I have 1, the degree of the top is smaller than the degree of the bottom, and so I'm going to go with y equals 0 for a horizontal asymptote. So what's that going to look like? Well, let's go see. Vertical asymptote at 4, horizontal asymptote y equals 0. Please remember to label the asymptotes on your graphs if you want credit. I get -1/4 for my y-intercept. There are no x-intercepts. This curve will never be crossing that horizontal asymptote. Cool. Doink, doink. And a test point. If I plug a 5 in, I can plug that 5 here. I can plug that 5 here. I would rather just plug that 5 in here. 5 minus 4 is 1. 1 over 1 is 1. At 5, I have a value of 1. So I must have something like this. Okay, done. No. Where's the hole? See, this is not on the x-axis. I've got students who, because of this, they say x equals -2 is an x-intercept. Yeah, no, not in this problem. We canceled, and when we cancel, we graph what's left, and we put a hole here. Well, we don't force an x-intercept to exist where one doesn't exist. We have to be approaching this horizontal asymptote. So my hole is here, below that horizontal asymptote. And there's -2. Remember, you can find the y value of this hole by taking this x value and plugging it into this part that's left over. And I actually get -2 minus 4 is -6. So this would be -1/6 if I needed that y value. I will need to be able to do that in calculus, but in our class, no, not really so much. I'm much more concerned with all the people who want to force this hole to be on the x-axis, because it ain't there, people. It's got a y value of -1/6. It does not have a y value of 0. So stop. Okay, how about this one? Y equals 3x squared plus 4x plus 1 over x plus 2. Okay, graph away. See you in a few minutes. Well, hi. Did you factor that? I mean, I can do some stuff, like find that the y-intercept is +1/2. There we go. I can see that the degree on top is bigger than the degree on the bottom. So I'm not going to have a horizontal asymptote. I'm going to have a slant. And I'm going to need to do some long division to find it. But I can find the vertical asymptote, x equals -2. That is, unless this thing has a hole. How do I know if it has a hole? That's right. If a factor on top cancels a factor on the bottom, it has a hole. But I don't see any factors on top. Duh, we haven't factored it yet. So you've got to factor that. You can't just say, well, but it's not factored. No, start factoring. Okay, 1, 1, plus, plus. And on the bottom, x plus 2. So I now see that there are no holes because there is no canceling. Okay. But I also see that there are x-intercepts at -1 and -1/3. And as far as that slant asymptote goes, well, let's see. X plus 2 into 3x squared plus 4x plus 1. What do I multiply this by to turn it into that? Well, I need a 3x. And that's going to give me 3x squared plus 6x. Remember, with long division, we subtract. And so I'm going to have -2x plus 1. What do I multiply this by to turn it into that? I need a -2. Stop. There's your slant asymptote. Okay, I don't need to complete this. I just need that linear thing. Okay, so what do we have? We have slant asymptote like this, whose x-intercept would be 2/3 and whose y-intercept would be -2. I also see a vertical asymptote at -2. I think I need to move this a little bit. This is 2/3. This is -2. Yes. Vertical asymptote was at -2. So look, I did it again. It's kind of funny. Okay. There's -2 there. What else do I know? A y-intercept of +1/2. I see x-intercepts at -1 and -1/3. Ooh, interesting. They're so close to each other. Yep, and that's okay. I'm not scared of that because what I know is happening here is I'm coming down, I'm going back, up, this away. Okay? And if I plug in a test point like -3, I want to find out if the y value I get is here, above the slant asymptote, or here, below the slant asymptote. This slant asymptote equation, 3x minus 2, if I plug a -3 in, -3 times 3 is -9, minus 2 is -11. We know the y value here is -11. I'm wondering if when I plug in a -3, do I get something up here or down here? Well, let's see what happens. We had factored the top as 3x, x, 1, 1, plus over x plus 2. And the reason I'm thinking about that is because for me, plugging that -3 in here in the factored form is easier than plugging the -3 in here. You could do either, doesn't matter. But for me, a little easier here because I don't have to worry about squaring. So if I plug in a -3, I get -9 plus 1 is -8 times -3 plus 1 is -2. -8 times -2 is positive 16 on top. And if we plug in a -3 on the bottom, -3 plus 2 is -1. So I get a y value of -1 over 16. Well, we found out that this was -11. -16 is even further down. So I got something like that. And please label that point. That point again was -3, -16. Okay, there's my graph. Were there any holes? No, no holes there. How about this one? Y equals x to the third plus 7x squared plus 10x over x squared plus 5x plus 6. Well, yeah, first thing I want to do here is factor. I'm going to GCF out that x from all the terms, and then I'm going to factor that trinomial. This factors as x plus 5, x plus 2. The bottom also factors as x plus 3, x plus 2. And because of this, I see that there's a hole at x equals -2. There's a vertical asymptote at x equals -3. There are x-intercepts at 0 and -5. And my y-intercept? Well, if you plug in 0 for all these x's, you end up with 0 over 6 or 0. There are 0 pizzas on the table. You and 5 of your friends show up. Yeah, you're not having pizza. So let's think about this graph. Ooh, wait, this degree is bigger than that degree. Slant asymptote. So you can do slant asymptote with this one. You can do slant asymptote with this one. You should be comfortable either way. I would probably do this into x squared plus 5x, but I think many people will start over here, so that's the one I'm going to demonstrate. X squared plus 5x plus 6 goes into x to the third, 7x squared plus 10x. What do I multiply that by to turn it into that? An x plus 5x squared plus 6x, and subtract. These cancel. 7x squared minus 5x squared is 2x squared. 10 minus 6 is 4x. So what do I multiply this by to turn into that? Just a 2. And so there's my slant asymptote. All right, so let's give it a graph. I usually start with the slant asymptote. Y equals x plus 2, 2, -2. We know that there's a vertical asymptote at -3. We know that there's an x-intercept at 0 and at -5, and a y-intercept here at 0. Well, I don't know how much I need because I think I see everything I need. From this point, I have to bend to that asymptote and bend to that asymptote. From this point, I need to bend to this asymptote, and I need to bend to this asymptote down here. Okay, there's my graph. Oh, but wait, no, there's a hole. -2. Please don't lose the hole. Problem has to be marked wrong if you lose the hole. Okay, last one. Y equals x squared plus x minus 6 over x plus 3. Please pause the video, give that one a graph. Hey, welcome back. That's right, I agree with you. I see that my y-intercept is -6 over 3, so the y-intercept is -2. I also see what looks like a vertical asymptote at -3, but I'm thinking maybe I should try and factor, because I might see, hey look, these are the same. And so there's no vertical asymptote. There is a hole at x equals -3, and there's only one x-intercept at -2. Okay, this is what I'm supposed to graph. That stuff that's left over. That's just the line y equals x minus 2. So this would be 2, and this would be -2. But don't forget the hole at -3. Okay, nice. I agree. Slant asymptote. Let's take a look. So I have to divide this by this. We get x plus 3 into x squared plus x minus 6. What do I multiply this by to turn it into that? And then I distribute and subtract. What do I have to multiply this by to turn it into that? So that's my slant asymptote. Notice anything about the slant asymptote and the what's left over stuff? That's right, they're the same. This graph right here sits exactly on top of that slant asymptote. So I'm not going to see a slant asymptote there. That's all I'm going to see is this. Maybe if I could look through the hole, I would see the dotted line of the asymptote. But yeah, no, don't go there. I'd rather see the hole. All right, well, I hope this was a helpful review, and I really hope you took the opportunity to practice this a bit. Some of you feel frustrated. I'm not comfortable with math, but hiding from it, not asking questions, not practicing, not trying, it's not going to change the state. You're still not going to know the math unless you start stepping up. Please ask questions. People who ask questions, they're really smart. Okay, take care, everyone.